Alrighty, moving on to lesson 5.5, compare and order rational numbers. So this lesson is very similar to a lesson that we've already worked with. It was lesson 2.5, where we compared and ordered fractions, decimals, and percents. If you can recall in 2.5, when we were comparing a fraction and a decimal, we had to make all of them the same form. So a fraction and a decimal, we had to make both fractions or both decimals. And it totally depended on what you felt most comfortable with. When we compared decimals and percents, you had to make both of them decimals or both of them percents before you could compare them. Again, it didn't matter which, but you had to convert them to the same form. The same thing applies to lesson 5.5. You're doing the exact same thing. You might be given two fractions. Perfect. Give them common denominators first and then compare them. Or you might be given a decimal and a fraction. Make both of them decimals or make both of them fractions, right? It doesn't matter. Do whichever you feel most comfortable with. This lesson, I will say, because we're working on converting a fraction to a decimal, I will be converting all of the fractions to decimals before comparing, just so you know. But two very important bullet points here. If comparing fractions, you have to have a common denominator before you can start comparing them. If comparing two different forms, like a fraction and a decimal, you have to make them the same form, both a decimal. Then we use inequalities to compare them, right? Our greater than sign, our less than sign, or our equal to sign. Alrighty, example 1. We've got -3/8 and -5/16. Let's recall, how do we know which number has a smaller value? If we're comparing two negatives, how do we know which one is the smaller one? How do we know which number has the smaller value? Remember, the smaller value is the number that's farthest away from 0 on the number line. The farther away the number is from 0, the smaller the value it has. So keep that in mind, super important. So here we've got two fractions. So I don't need to make these decimals, right? They're already fractions. I just have to make sure that we have common denominators. So looking at 3/8 and 5/16, hopefully we see that our common denominator would be 16. So I'm going to rewrite 3/8 to have a denominator of 16. So I've got to multiply, my 8 by 2. 8 by 2 to get 16. What I do to the bottom, I do to the top. So I multiply the top by 2 and I get 6. Now don't forget that both of these are negatives, and I'm just going to rewrite my entire problem. Now, when comparing them, I recommend writing a small number line to compare them. And since these two fractions are between 0 and -1 whole, right? Because it's not a whole yet, it's not a mixed number, it's a fraction, which means it's not quite a whole. It would be 16 out of 16 if it were a whole. So it's between 0 and -1. I'm going to just it's not going to be perfect, but I'm going to put them in order. Which of these numbers is closest to 0? Which numerator, right? Just like positive fractions, we compare the numerators. With negative fractions, we also compare the numerators. Which numerator is closer to 0? We've got -5 and -6. -5 would go here, so I'm going to put -5/16. -6/16 would be a little bit closer to the -1. And this is just for our sake, it doesn't have to be perfect. So which number is farthest away from 0? The -6/16, which means -6/16 is less than, because it's farther away, it has the smaller value, -5/16. Alrighty, example 2. I believe I went, yes, this way. Again, I'm comparing two fractions here. And whenever we're comparing two fractions, comparing a fraction, decimal, comparing whatever, I highly recommend making this little number line over here that I've got in purple, just to give us an idea of which one's closer, which one's farther from 0. Remember, if we kept this number line going, it would be 1, 2, right? If we kept it going in this direction, it would be -2. So, but I only care about the 0 and -1 because that's what these two fractions are between. It's not a mixed number. So I don't need to draw this orange part of the number line. Okay, so I've got two fractions, which means I can use a common denominator to compare. -3/14 and -2/7. My common denominator will end up being 14. So what do we have to do to 7 to get to 14? Multiply by 2. What you do to the bottom, you do to the top. So 7 times 2 is 14. 2 times 2 is 4. Don't forget that these are negative fractions. I'm going to rewrite my original fraction over here. Now, on my number line, I'm just going to kind of very sloppily place these. I'm comparing the numerators. So I've got -3 and -4. Well, -3 will be generally here, and then -4 will be after, so it'll be a little bit closer to that -1. So which number is farthest away from 0? The -4. So the -4 has the smaller value, which means the -3 is greater than the -4. Alrighty, example 3. I think it's back over here, yep. Example 3. Again, I've got two fractions, so and they're both negative, I immediately draw my little number line. Alright, my common denominator. I have to have a common denominator before I can compare. My common denominator in this case would be 10. So I multiply this fraction by 2, right? 5 times 2 gives us 10, which means what I do at the bottom, I do to the top. Get 4. Don't forget the negatives, bring them down. Alrighty, let's kind of sloppily put these on the number line. I've got -4/10 and -3/10. Well, 3/10 is closer to 0/10, right? So -3/10, -4/10 is closer to -10/10, right? So that's closer to 1 whole. Therefore, which number is farthest away from 0? The -4, which means it has a smaller value. -4/10 is less than -3/10. Alrighty, example 4. Here's where we're moving into these decimals. So I've got a decimal and I've got a fraction. I recommend, because these fractions are going to be kind of gross and the common denominators might be a little difficult to find, I recommend making these fractions into decimals, which means that's what we did last section, right? 5.4. So we're just going to divide, right? 8 divided by 15. Numerator always goes inside the doghouse. So let's convert 8/15 to a decimal, which means 8 goes inside the doghouse, 15 goes outside of the doghouse. Can 15 go into 8? Nope. So I put a little X there. And then I know I have to add a decimal and a 0. 15 can go into 80. How many times? If you're not sure, let's do a little side work. Let's do 15 times 5. 5 times 5 is 25. 5 times 1 is 5. Plus 2 is 7. Perfect. So it goes in 5 times to give us 75. Subtract. We get 5. Add a 0, bring it down. How many times can 15 go into 50? Well, 15 times 3 gives us 45. Subtract, get 5, add a 0, bring it down. And what are we going to notice is going to happen? Goes in 3 times to get 45. That 3 is going to start repeating. So this, let's rewrite this. This 8/15ths would actually be negative 0.53 with the bar over the 3 because the 3 is repeating. Alrighty, and then I bring everything else down. And now I have to compare these two decimals. So I've got two negatives. It's kind of like negative 0.51 and negative 0.53. Which of those numbers is closest to 0? Well, you could also look at it like negative 51 and negative 53 if the decimal is throwing you off. So negative 51 is closer to 0. So it's negative 0.51. Negative 53.53 is closer to 1 whole. So negative 0.53. Which means, which number is farthest away from 0? It's the 0.53, which means that has a smaller value. Which means this 0.51 is greater than negative 0.53. Alrighty, let's go ahead and move on to example 5. Oh, before we get to example 5, let's work through a few got it's. Page 388, A, B, C, and D. I'll pause the video and we'll use the chat box. Alrighty, I believe this is actually example 5, not example 4. Yeah, so this is example 5. Alrighty, we've got two decimals, perfect. Before you think too hard about this, notice that the decimal on the left, negative 1.2, is negative. The decimal on the right, 0.8, is positive. You don't have to worry about the little number line when you're dealing with a positive and a negative number. You only have to deal with the little number line when you're dealing with two negative numbers. So automatically, right off the bat, we should know that this negative 1.2, negative, is less than positive. Alrighty, example 5. Here we've got two decimals, right? In this decimal, both of these have whole numbers. So instead of them being between 0 and 1, now it's kind of like a mixed number, right? So this decimal is between negative 1 and negative 2. So keep that in mind when making your little number line. But again, whichever one is closest to 0 or whichever one is farthest away from 0, we've got our rules. So be careful with that. And since they're both decimals, we don't have to change anything about them. We don't have to change the form. We just have to put them on our number line. So negative 1.4. That's about here, negative 1.4. Negative 1.25, is that closer to negative 2 or negative 1? Closer to negative 1. And then the question is, well, negative 1 and negative 2, which one's closer to 0? Negative 1, right? So the number that's closer to -2 would mean that number is farthest away from 0, which means -1.4 is less than -1.25. Alrighty, last but not least, example 6. -3 5/8 and -3.625. So we've got a mixed number and a decimal. We need to make this mixed number into a decimal so that we can compare them. Alrighty, so remember, you do not have to worry about this whole number. That whole number just stays. We're going to need it later, so I'm going to put it over here. All we have to worry about is this 5/8. So 5 is the numerator, goes inside the doghouse, 8's on the outside. Can 8 go into 5? Nope. So we add a decimal, add a 0. Can 8 go into 50? Yes. 6 times, right? To get 48. Subtract, we get 2. Add a 0, bring it down. Can 8 go into 20? Yes. Twice, right? To get 16. 20 minus 16 is 4. Add a 0, bring it down. 8 does go into 40 5 times exactly. Alrighty, which means we're finished with that division. But we're not really finished. We've got to tack this decimal, back onto our original over here. So it is -3.625. So now I'm going to rewrite our expression, our inequality, -3.625, and I'm comparing it to -3.625. So awesome, same number, which means they are equivalent. Alrighty, we're going to complete a few more got it's on page 389, E through F.